Yes. Hi, children. So after Newland's octave of waves, then there comes Mendeleev's periodic law. Mendeleev has come into picture. Mendeleev's periodic law states that the properties of elements are periodic functions of their atomic masses. So they are the atomic masses. So here the arrangement of elements have been taken place based on their atomic masses. So let us see in detail about this Mendeleev's periodic table. Mendeleev's periodic table has six horizontal rows. See here, six horizontal rows. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 here. So six are horizontal rows called as periods. Rows are called as periods and eight vertical rows called as groups. Rows, columns are called as groups. All right. The groups 1 to 7 had two subgroups called as A subgroup and B subgroup respectively. See here, they have two subgroups as well, A and B. Group 8 has three rows of elements. See here, group 8 he has considered in a different group. So it has three subgroups, iron, cobalt and nickel. See, you see that the extreme right hand side. Elements having similar properties were placed in the same groups. There are some spaces left vacant in the table to accommodate if there were any further new discovery of elements happens. This Mendeleev has put some spaces in the middle. See for accommodation of these elements. Okay. So in the future. So this is about Mendeleev's periodic table. What does he says is the horizontal rows, six horizontal rows are there. They are called as periods, and seven vertical columns are there. They are called as groups. Okay, and each group has two subgroups A and B respectively, and the extreme eighth group has three subgroups respectively. Okay, and he also left some few spaces in the middle to accommodate any discovery if any element if it happens in the future. So let us see what are the merits of Mendeleev's periodic table. Elements were classified on a more fundamental basis on their atomic masses and properties. Like every other, spaces were left vacant. The main first merit is spaces were left vacant. That means he has thought for the future also, for the next coming scientists also. It could predict the properties of the elements which helped in the discovery of new elements. That means as he left spaces so that it could predict the future properties of the elements. The inert gas elements discovered later could be placed in a separate group without disturbing the table. The inert gases, which are inert in nature, has been kept far apart without disturbing other elements which have been discovered in the before up to seventh group. Okay, yeah, these are the merits of the Mendeleev's periodic table. Let us see what are the demerits of Mendeleev's periodic table. Some elements are not arranged in the increasing order of their atomic masses at all. For example, cobalt is placed before nickel. See here, if you see this in this, cobalt is placed before nickel. That means it has 58.7 and this has 58.9. This is not based on their atomic masses, right? This is one of the main defects. Te is placed in before iridium. Tellurium is placed before iridium. Tellurium is placed before iridium. See, it is 192 and tellurium will be around 128 is placed before iridium. And then position of hydrogen is not clear because it shows properties similar to metals as well as non-metals. Position of hydrogen he did not explain about it at all because see here it is at the top left corner and he did not talk anything about this hydrogen because it shows similar properties both non-metals as well as non-metal. The position of isotopes of elements is not clear and he didn't speak much about these isotopes. This is about Mendeleev's periodic table. And we shall see in the next class about this modern periodic law.